Let's practice the functions that you learned in the previous video on a different vector of the glc.sample package on gr_communication_skill. Before that, you need to load the package glc.sample that contains it with the library function as usual. Now you can browse through the gr_communication_skill vector with the RStudio's view function. The members of this vector represent the 100 students' communication skills level in Greek. Passing an eye over the vector's elements, you can observe that the students' communication performance in Greek is very good. Now, let's ask for the length of the vector. No surprise, it is 100. Next step is to get the first n items of the vector. I chose its first 30 members, and for the last 30 members you need the tail function. What about the unique elements of the vector? Or else, how many assessment levels have been recorded? For this, you can use the unique function that outputs a vector with 5 members in our case. Although the number of unique elements is small, you will often deal with character vectors that contain a big number of unique members. In order to get the number of the distinct members of the vector, you can use the unique function in combination with the length function that accepts as its argument the vector returned by the unique function. As you can see, the unique function is placed inside the parentheses of the length function. This is possible to do since R evaluates the expression in a from inside out fashion. What I mean by that is that when R deals with nested expressions such as this one, it first evaluates the most deeply nested expression, the one that is inside the parentheses, then it gets the returning value, a vector in the case of unique, and passes it back as the argument to the length function. That is why the length function takes as its argument the vector with the unique elements of gr_communication_skill and returns its length. Of course, you could achieve the exact same thing in 2 steps. You could first assign the resulting vector of the unique function to a variable, as I did here with the unique_communication variable, and then insert the variable as argument to the length function. If you're feeling shaky as to what an R variable is, check out the earlier video that explains the concept in detail. Here is the code summary so far. Feel free to pause the video if you like and take a look at it. Until now, we worked with character vectors loaded from the glc.sample package. What if you wanted to create your own vector? That would be the case if you had a small dataset or if you wanted to test some hypothesis on a sample of data. And for that, you needed to hard-code it into an R character vector. So, combining some character values into a vector can be achieved with a C function. Here, I combine the 3 strings, Greek, English, and German, into a new character vector. R's interpreter evaluates the expression and displays the resulting vector. Of course, you can assign the vector to a new variable so that you can access it later, as I just did here with a variable called languages. So, let's bring it all together and see how we could do something more creative with our data and with the freshly acquired knowledge. Let's assume that we would like to create a new vector with 2 elements, the numbers of unique elements in the 2 character vectors glc_L1 and gr_communication_skill. The first step is to think of how to get the unique elements of the 2 vectors. That is something you already know how to do, and you saw it in this and the last video. Next step is to think of how you could get the length of the vectors returned by the unique function. That you also know and just saw a minute ago. Each of the values returned by the last 2 statements will be an entry in the new vector. So what remains to be done is to put these 2 code chunks together in the same vector. And you can do that by using the C function that constructs a vector. Its arguments will be the members of the new vector. That means we put the two earlier code chunks inside the parentheses of the C function and separate them with comma, as we do to a function that accepts more than one argument. Finally, we store the resulting vector to the variable lengths so that we can access it later. By calling it, you can see that it has two numbers as its elements, 5 and 10, for the number of distinct languages and the number of distinct assessment levels of the GLC_L1 and the GR_communication_skill vectors correspondingly. There is nothing special about this seemingly complex code chunk. Rewind what I said a minute ago about the way R deals with nested expressions, namely by evaluating from inside out any complex code expression, and you will see how the complexity vanishes. Now it's your turn to do something with the data. So, here are two code chunks I prepared for you. I would like you to tell me which of them, number 1 or number 2, returns the length of unique elements of the first 50 members of GLC_L1. Feel free to pause the video, run both code chunks, and think about the output you get. I'm looking forward to receiving your answers or any question that may have come up in the comments section below. I will come back to the solution of this short exercise in the next video. Decoding mentally the way that R evaluates nested expressions is definitely the first and decisive step to understanding R code and creating your own R programs. Don't forget to also subscribe to the channel by pressing the relevant button on the video or on channel's homepage, and then, in order to get updates when new videos are released, you need to activate the bell notification that stands on channel's homepage.